This is section 1.4, which is building functions from functions. The AP Precalculus standard that this is tied to is 2.7, which is composition of functions. So the first thing that we're looking at is defining new functions algebraically. So if we are given f of x equals x squared, g of x equals square root of x plus 1, and h of x equals 3x minus 2, we're finding the different combinations and compositions of functions. So the first one is f plus g of x. So if we're taking f of x and g of x and we're adding them together, we're just going to get x squared plus the square root of x plus 1. Since we don't have any like terms there, we can't add anything together, so that is actually our final answer. For each of these, we're going to talk about the domain as well, because it's good practice finding our domain. So because we have a square root in there, we can't have anything that is negative underneath the square root. So we have to think, what would make it equal 0? Well, that would be -1. And it needs to be all numbers bigger than -1 so that we don't have a negative number underneath the square root. So we would say square brackets, -1 to infinity would be our domain. Okay, our next one is f minus h of x. So that's going to be x squared minus 3x minus 2. And you'll notice I put parentheses around the 3x minus 2. That's super important because we're not just subtracting the first term, we're subtracting the whole equation. So we need to put the parentheses there to remind us to distribute. So that would give us x squared minus 3x plus 2. And our domain for that one, since we don't have any fractions, we don't have any square roots, our domain is just going to be all real numbers, or negative infinity to positive infinity. Okay, our next one is f times h of x. So we're going to take our x squared times 3x minus 2. So that's just distributing. We end up with 3x to the third minus 2x squared. Again, no fractions, no square roots. So our domain is just negative infinity to positive infinity. And our last one is f divided by g of x. So we have a fraction going on. So we are going to do x squared over the square root of x plus 1. And a lot of times, even though this is an expression and we technically could stop at this point, we oftentimes don't like to leave radicals in the denominator. So we want to do what's called rationalize the denominator. So to do that, we're going to multiply by what the square root is in the denominator. So I'm going to multiply top and bottom equation of the equation by square root of x plus 1. So what that's going to do is going to give us x plus 1 in the denominator because the square roots would cancel out, and we end up with x squared times the square root of x plus 1 in the numerator. So that's my expression, and then I have to think about the domain. So there's two things going on, and I'm going to especially focus on this original equation that we have. So we have a square root and we have a fraction. So you have to think about both of these. So the first thing I'm going to think about is the square root. So I know that my numbers need to be -1 and bigger because I know that from part A. But then now it's also the bottom part of a fraction. We're dividing by it, which means that we can't have 0 in the denominator either. So what that's going to do is change that square bracket that we have to a parentheses. Oops. So this would be parentheses -1 to infinity. Okay, next is composition of functions. So this is where we're plugging a function into another function. So how this works is I'm going to write two different ways that you might see it. So you see the f of g of x. So that open circle in between the f and the g, it's not multiplication. And a lot of kids try to treat it as multiplication. It's not multiplication. It is of. It's a composition. So What this is the same as is it's the same as if you saw f of g of x written like that. So those two notations are equivalent to each other. So being able to recognize that those mean the same thing, that's very important. So what this means is we would plug g into f. So here you see we're plugging g into f. So what that tells me is that f is kind of the format of my function. So I'm taking my f of x equation, I'm going to put parentheses squared minus 1. So I'm going to take the x out and I'm going to plug g of x in its space. So that means that x, the square root of x, is going in there. So now, if I simplify that, I just get x minus 1. But what you have to be careful of with the domain here is that you have to realize that we had a lot of steps along the way. So even though our final answer is x minus 1, and we could plug any number we want if it's x minus 1, we had a square root along the way that we have to think about. So if our original number that we're plugging in is a negative number, we can't do that. So that tells us that our domain is going to have to be 0 to infinity. It could be 0 because we can take the square root of 0. So we have to deal with positive numbers because the first step is to plug the number into the square root. Okay, our next example is the opposite. So this time we're taking f of x and we're plugging it into g. So if we look at g, g is the square root of x. So I always leave the x out and leave a blank. You could put parentheses in that blank, but then we're going to put f of x there. So that'd be x squared minus 1. So key thing, the square root and the square do not cancel in this case because we have that minus in there. So we can't just cancel things out. So this is going to be our simplified answer. I'm just going to write it without parentheses, the square root of x squared minus 1. So since our first step was f of x, we don't have any restrictions on what the domain of f of x can be. But once we take f of x and put it into g of x, we have a square root and we know we can't have a negative in there. So we have to think about what numbers would cause us to have an issue with that final result. So we know that 1 squared minus 1 would give us 0, but also negative 1, because negative 1 squared turns out to be positive 1, minus 1 is also 0. So we have 1 and negative 1, and if we plug in a number between those, like 0, 0 minus 1 gives us a negative number. But if we plug in a number outside of that 1 and negative 1, we get like 2. 2 squared is 4, minus 1 is 3. So that works. So our domain is going to be negative infinity to 1. I'm going to use the union symbol. And 1, sorry, that should be negative 1. Okay, so negative infinity to negative 1, and then positive 1 to positive infinity. Okay, now the last one here is, what do we do if there's a number? So if there's a number, this means you're taking 9 and you're plugging it into G, and then you're taking that answer and plugging it into F. So if we start with G of 9, so G of 9 would be the square root of 9, which is 3. So then to find F of G of 9, you're going to find F of 3. So F of 3 would be 3 squared minus 1, which is 8. So if you're finding the composition of functions of a number, that's kind of the chain of events that you're doing. Okay, our final example for this section is a piecewise function. So we're reviewing how do we graph piecewise functions. So I'm going to use different colors here so that we can see. So what we're going to do to start with is we're going to take any restrictions, so any of the inequalities that we have over at the right, and we're going to plug it in over on the left. So I'm going to take the negative 3 and I'm going to plug it in right here. So negative 2x, negative 2, so negative 2 times negative 3 minus 3. So that would be 6 minus 3, which is 3. So what that point is my input was -3 and my output was 3. So I know I have the point -3, 3. And I know it's going to be an open circle because that symbol right there, that less than symbol, is not less than or equal to. So I'm going to go to -3, 3, and put an open circle. Now, I know that this is true for all x's that are less than -3. So that means everywhere to the left. And I know that that's just a line that has a slope of -2. So I'm going to continue my line. Bad drawing on here, but I'm going to continue my line to the left, and it has a slope of -2 because I can see that right there, that's what I'm dealing with. Okay, next color, let's go with green. Okay, for the middle one, I have a -3, and if I plug in a -3, there is nowhere for me to plug a -3 into. So I know that I'm going to have the point -3 is what I put in, and it's always going to come out as -1. Same thing if I try to plug 2 in. It's just a number over there. So I plugged 2 in, and I got -1 out. So that means that I have those 2 points, and I know that if I have f of x equals -1, that's just a horizontal line. So at -3, I'm looking at my symbol right there, it's a less than or equal to. So I'm going to go to -3, -1, and I'm going to try to draw a dot here that is colored in. Okay, and then I'm going to go to 2, -1, and I'm going to do an open circle, and I'm going to connect. Let's try that. Okay. So then my last one, let's go with blue. I'm going to plug in the 2 in right here. So I have 1/2 times 2 squared. So that would be 4 times 1/2, which is 2. So my input was 2 and my output was 2. So I'm going to go to 2, 2, and I know that that is a colored in dot. Okay, so then this last portion is quadratic. I know it's quadratic, so it might be helpful to plug in a few extra points. So if I plug in 3 squared, so I'm going to get 9 times 1/2, which would be 4.5. So I can go to 3, 1, 2, 3, 4 and 1/2 and put a little dot right there. And then if I did 1/2, oops, I'm running out of space here. 1/2 times 4, so it'd be 16 times 1/2, it would be 8. So I have the point 4, 8. So over 1, 2, 3, 4, up 1, 2, 3, 4, 5, 6, 7, 8, like off my graph. So we can see there's a slight curve to it, but it's quadratic. So that is just kind of a quick review of how we graph piecewise functions.